Someday, in the not-too-distant future, a piloted glider will make a flight around the world. After circling the Earth, the pilot will control his re-entry and landing at a selected airfield. As the ship descends from the rim of outer space at more than 18,000 miles an hour, the denser atmosphere sets up a glow in the glider's skin, parts of which look like a white-hot poker. To protect the pilot against the rigors of atmospheric re-entry requires the latest developments in aerothermodynamics, heat-resistant metals, rugged structural design with a minimum weight penalty, reliable communications, effective flight controls, and precise guidance. In the end, it takes the cool hand of a skilled pilot to bring his glider in for a conventional landing. This is DynaSoar, a dynamic soaring vehicle.
Under this tarpaulin is a full-scale mock-up of the DynaSoar glider currently being developed by the United States Air Force. And this is a model of the glider our Air Force test pilots will be flying. Compared to modern aircraft, it isn't especially large. Not for a vehicle that's going as far and as fast as this one. But what we see here represents a major achievement in aerodynamics. To design and fabricate a vehicle that will stand up under the punishment a glider like this must undergo calls for the finest know-how we have, from drawing board to the actual hardware itself, not to mention some first-rate piloting. For this DynaSoar project puts an emphasis on the pilot, on the man. In 1958, the Air Force, after consideration of several design and feasibility studies, established the DynaSoar System Program Office at Wright-Patterson Air Force Base, Ohio.
Gentlemen, the individual responsible for the development of the system is General Bernard Schriever, Commander of the Air Force Systems Command. General Schriever.
Well, ladies and gentlemen, as all of you know, there's been a great deal of work already done on the X-20 program. Years of study and research have preceded the design of this particular vehicle. As Dr. Cherrick pointed out, the X-15 has been a very worthy forerunner of the X-20.
To carry the DynaSoar project to completion, an orderly flight test program has been planned. During the first phase, the pilot and glider will undergo airdrops from a mother ship. On these flights, the glider will use a rocket engine to achieve the necessary speed for a test of its aerodynamic characteristics and its functional subsystems. These airdrops will be followed by the launching of unmanned gliders for flights down the Atlantic missile range. Later, there will be piloted probes out over the Atlantic, with landings at downrange sites. When all systems and components have been successfully tested, the DynaSoar will be ready for its orbital mission. The pilot's safety is a prime consideration. For what he learns out there will affect the concept of manned operations in aerospace for years to come.
Perhaps now you may sense some of the interplay of men and ideas in industry and government which must be brought together to accomplish the DynaSoar experiment. Why are we doing all this? Why DynaSoar? Because with DynaSoar, we're establishing a new technology that enables us to extend Air Force operational capabilities into the hypersonic and orbital flight regimes. Future outgrowths of DynaSoar may very well assume vital roles in our national defense. Through this program, we are making use of what we've already accomplished in the missile, space, and aeronautical sciences. DynaSoar is as fundamental to future space operations as were the early experiments at Kitty Hawk. By putting man at the controls, the Air Force has carried forward into space that journey started by the Wright brothers a little more than a half a century ago.